Hey everybody, and welcome to another deep dive. Today, we're going to be tackling refrigeration system diagnostics.
Okay.
So maybe you're prepping for some big exam,
Mhm.
or you're brushing up on your skills for work, or maybe you're just kind of curious about how these systems actually work.
Oh, yeah, I think there's a lot of people
So one's a
that
cheaper shoe.
are ice cream from melting.
Yeah, exactly.
But either way,
Mm-hmm.
we've got a whole stack of study guides, troubleshooting briefs,
Wow, that's a lot of...
and even a couple
Like-
pressure temperature charts for like
Okay.
a common refrigerant.
Gotcha.
And, you know, I think one of the things that I found really interesting was just this idea that like the weather outside can actually affect your fridge.
Oh, interesting.
I mean, that's one of the things that we're going to unpack
Yeah, I'm excited to learn about that.
as we deep dive into all of this.
Yes. So I guess like maybe a good place to start is just
Yeah.
understanding like the mechanics of how. Yes. So how does a refrigeration system actually work?
A refrigeration system works.
I mean, I picture like a
Yeah.
bunch of tubes and refrigerant, but I don't know what's going on.
You're not wrong.
Okay.
So it all comes down to like this closed loop system, right?
Okay.
And there are these four key players we need to think about.
Right.
There's the compressor,
Okay.
the condenser, the evaporator,
Mm-hmm.
and the expansion valve.
Okay.
And it's almost like thinking of it like a relay race where each component is passing the baton to the next.
I like that.
Yeah.
And in our source material, there's this thing called the heat pump illustration.
Oh, right.
Do you think maybe we can use that to kind of walk through
It totally.
this whole process?
Yeah, absolutely. So why don't we start with the compressor?
Okay.
So think of the compressor as like the heart of the whole system.
Right.
Because it's the component that's pumping that refrigerant, which is like our runner
Okay.
throughout this loop. And if you look at that illustration, you'll see that the refrigerant enters that evaporator
Mm-hmm.
as a cool liquid,
Okay.
and it's at low pressure at this point.
Okay.
And it's basically just ready to absorb heat.
So it's like our runner's
Right.
relaxed and
Exactly.
ready to go at this point.
Ready to go. And then as it moves through that evaporator, which is that cold section inside your fridge,
Okay.
it's absorbing that heat,
Mm.
right?
Uh-huh.
And as it absorbs heat, it changes state from a liquid to a gas.
Okay.
So it's like a runner's getting energized,
Oh.
picking up speed.
So it soaks up the heat from the fridge, turns into a gas.
Exactly.
Where does it go next?
Condenser. You got it.
Oh.
To the condenser.
Okay.
So then from there, the compressor
Mm. Yeah.
actually pressurizes that refrigerant, right?
Okay.
That's now gaseous.
Okay.
And it sends it off to the condenser.
Okay.
So now it's hot
Uh-huh.
and it's high pressure.
Okay.
Like our runner's really putting in the effort here. Okay. And in the condenser, the heat's released to the outside air
Oh, okay.
and the refrigerant condenses back into a liquid.
So is that why the back of my fridge feels warm?
That's exactly why.
Oh,
It's
okay.
all that heat being released.
Gotcha.
So it's like our runner's taking a cool down break,
Okay.
releasing all that built up energy.
Okay. So what happens next?
Well, now our runner needs to like slow down, get ready for the next leg of the race, right?
Okay.
That's where the expansion valve comes in,
Okay.
and it restricts the flow of that liquid refrigerant,
Okay.
causing a pressure drop.
Okay.
So it's almost like, narrowing the track,
Okay.
forcing the runner to slow down,
Okay.
cool off a little bit.
Gotcha.
And this basically just prepares the refrigerant to absorb heat all over again as it re-enters that evaporator,
Okay.
and we start the whole cycle over.
Wow. That's pretty
Yeah, it's amazing
amazing when you think about it.
when you really break it down.
Yeah. A continuous loop,
Mm-hmm.
all thanks to these
Four components working in sync.
working together.
Okay, so, but what about when things go wrong?
Yes.
That's what I really
The
want.
dreaded malfunctions.
Exactly.
So that's where diagnostics come
Okay.
in, right? So our sources,
Okay.
they talk about a bunch of common symptoms,
Right.
right? Like insufficient cooling.
Yeah.
Maybe you've got that annoying sound of your fridge constantly running.
Uh-huh.
Maybe some strange noises.
Yeah. We've all been there.
We've all been there. It's like, where do you even...
Yeah, it's like
So-
trying to decipher a secret code.
Yeah. So I think where do we... Before we dive into the pressure gauges and charts and all that,
Okay.
we should probably rule out the simple stuff.
Okay.
You know?
Uh-huh.
Like, is it plugged in?
Right, yeah.
Is the thermostat set correctly?
Yeah.
You'd be surprised.
No, those are good points, though, because
Calvin does.
sometimes it is the
And the
opposite.
culprits.
Exactly. And what about those
Dirty condenser.
weird condenser coils?
Right.
Yeah.
Right.
So remember, those can
Like those restrict airflow.
restrict airflow. It's like,
And they make the system work harder.
right. trying to run a race wearing a heavy coat.
Yeah, exactly.
Yeah. Yeah. And you know,
Okay.
it's not just about the fridge working harder, though.
Right.
It can actually shorten its lifespan
Oh, really?
and cost you more in electricity.
Oh, wow.
So cleaning those coils,
Okay.
it's like a simple maintenance task,
Yeah.
but it can make a really big difference.
Okay. Good point. Clean coils, happy coils.
Exactly.
But what if it's more
They're
than...
just dust bunnies.
Sometimes it is more than just dust bunnies. So our source material highlights one component that is really crucial,
Okay.
and that's the compressor.
Okay.
And they talk about a really simple test that we can actually do.
Yeah.
Using a multimeter, which is that tool for measuring electrical properties.
Now, I'll admit I'm a little intimidated
Yeah.
by my electrical stuff, so
Yeah.
what exactly are we...
So
See, basically,
when we test the compressor with a multimeter.
think of it this way. We're checking the compressor's electrical heartbeat.
Okay.
So we're looking for specific resistance readings between the compressor terminals.
Okay.
And according to our source material, those readings should be around 10 ohms, 6 ohms, and 4 ohms.
So if we see no resistance,
Right.
that's like a flat line for the compressor.
Yeah, not a good sign.
Bad sign.
No resistance usually means that the compressor has failed,
Oh.
and that's a major repair.
Okay.
So, catching that early on with this simple multimeter test could actually
That's like a preventative checkup
save you a lot of headache.
down the road.
For sure. Okay, that makes sense. So, I'm curious about something, though.
Yeah.
So we talked about earlier how even the weather outside can impact our fridges.
Yeah, it's a weird one, right?
So how does that...
It is. So one of the things that surprised me when I first learned about these systems
Yeah.
was the impact of ambient temperature,
Uh-huh.
especially in colder climates.
So even something like the temperature outside can influence how my fridge operates.
It can.
Okay.
And it especially impacts when it comes to suction pressure and superheat,
Okay.
which are these key indicators of system performance.
Okay.
And what happens is those low ambient temperatures
Yeah.
can actually mimic an undercharged situation.
So it's like the fridge is getting tricked
Yeah,
by the cold weather.
It's like it's confused.
Okay, interesting. I never would have thought of that.
Yeah.
So you really have to consider
Yeah.
all these factors, not just what's happening inside
the fridge?
Yeah. Okay.
You have to look at the bigger picture.
That's really interesting. Well, are you ready to delve into the world of pressure readings and see how those can help us pinpoint problems?
Let's do it. I'm ready to break out those charts.
That's where those charts will come in handy.
Charts galore.
I'm ready to decode these readings and become a fridge whisperer.
Right. Let's do it.
All right, so we're ready to tackle these pressure readings.
Okay.
I'm looking at these charts
Hmm.
from the source material, and honestly, it's a bit overwhelming.
Yeah, it can be a little intimidating. It's kind of
Yeah.
like learning a new language almost.
Yeah, where do we
But once you understand those key phrases,
even begin?
it all starts to click.
Okay.
So we've got these two main pressures that we want to focus on.
All right.
Suction pressure and discharge pressure.
Okay.
So suction pressure, you can kind of think of it like checking the refrigerant's pulse as it enters the compressor.
Okay.
And then discharge pressure,
Mm-hmm.
that's measuring the pressure as it's leaving.
So it's kind of like measuring the refrigerant's blood pressure
Exactly.
before and after a workout.
Perfect analogy.
And how do those pressures
How about
help
here?
us diagnose problems?
Let's say you're noticing your fridge isn't cooling properly, right?
Okay.
And you check those pressures.
Okay.
If you're seeing that both the suction and discharge pressures are high,
Okay.
that could point to a restricted condenser coil. Remember those dirty coils?
So it's like a
Yeah.
traffic jam in the system.
Exactly. It's like a blockage.
The refrigerant can't...
Flow freely,
Yeah, the refrigerant can't flow freely.
causing pressure to build up on both sides.
Exactly, causing that pressure to build up.
Okay.
But what if we see a different pattern?
Okay.
What if we see low suction pressure
Yeah.
and high discharge pressure?
Okay.
That might suggest a different culprit altogether,
Okay.
possibly a restricted evaporator coil.
So the blockage is happening after the refrigerant absorbs
Exactly. So it's
Right.
happening,
heat in the evaporator after that point.
which is why the suction pressure is low,
Right.
but the discharge pressure is still high
Yeah, because it's struggling to get through.
because it's struggling to get through.
Yeah.
Okay, so it's fascinating.
It is fascinating
Look,
how
these pressure readings
those readings
It's-
can tell us so
can
much.
give us so many clues.
So we've got these pressure readings, but the source material also talks about superheat and subcooling.
Right, right.
What are those, and why should we care?
Well, if you're trying to figure out why your fridge isn't cooling properly.
Okay.
Superheat and subcooling can really help you narrow down that problem, maybe even fix it yourself.
Okay.
So think of superheat as a measure of how much hotter
Okay.
the refrigerant vapor is than it should be at a given pressure
Okay.
after it leaves that evaporator.
So it's like checking if the refrigerant is overheating after it's worked out in the evaporator.
Perfect analogy.
Yeah.
And subcooling.
Yeah.
Similar. Okay.
But we're looking at the liquid refrigerant as it leaves the condenser.
Okay.
So it's measuring how much colder that liquid is than it should be at a given pressure.
So just like with the pressure readings,
Exactly.
we can use these superheat and subcooling numbers to diagnose problems.
You got it. So for example, if you see low suction pressure and low superheat, that's a classic sign of an undercharge. Meaning there's not enough refrigerant in the system.
And on the flip side, an overcharged system would show high pressures, low superheat, and high subcooling.
You got it. But remember how we were talking about how that low outdoor temperature can sometimes trick the system?
Yeah.
Well, that can also affect your superheat readings, making it seem like there's an undercharge.
Oh, wow.
When there really isn't.
So we really have to consider the context.
You got it. It's not just about and all the factors involved.
Blindly following those numbers. Yeah. It's not just about blindly following.
You got to understand what they're telling you.
The numbers on the charts.
Exactly.
We need to understand what those numbers are telling us about the system as a whole.
Now, speaking of understanding pressure, there's this crucial component that kind of regulates it all. And that's the thermostatic expansion valve, or TXV.
Yeah.
Remember how we talked about it being like the gatekeeper?
Controls
the flow of refrigerant into the evaporator?
Exactly.
What happens if the TXV isn't working properly?
Well, a malfunctioning TXV can really throw the whole system off balance.
Oh.
You know, it's like having a faulty starting gate in our relay race, right? It can cause all of these delays, affect the outcome. And our study guide had a really good example of this. A poorly insulated TXV bulb.
What's the big deal about a poorly insulated bulb?
Well, the bulb is like the TXV's brain. You know, it's sensing
the temperature of the refrigerant vapor leaving the evaporator. If it's not properly insulated, that bulb can be influenced by all those surrounding temperatures, leading to inaccurate readings.
So it's getting false information.
Exactly.
Which could lead to
it's getting bad intel.
Making the wrong decisions about how much refrigerant to let through.
Yeah. And that can cause all sorts of problems, you know. Pressure imbalances, temperature imbalances in some cases. It can even lead to compressor failure.
Oh, wow.
So it's just a good reminder that even these small components can have a huge impact on the system.
You know, I never realized how much that little valve could affect the whole system. It's a good reminder that every part plays a role.
It does.
Yeah.
It does. And speaking of interconnectedness, we can't forget about the refrigerant itself.
Right. The lifeblood.
It's the lifeblood of the system. So
what do we need to know?
When it comes to refrigerants.
About different types of refrigerants.
Well, there's a whole world of refrigerants out there, each with their own properties and environmental impact. You know, you got the older refrigerants like R22, which are being phased out because they contribute to ozone depletion. And then you have those newer options like R410A, which is the one we have the pressure temperature chart for in our source material.
And I've been hearing a lot about these A2L refrigerants lately.
So A2Ls, those are a newer class of refrigerants. And they're mildly flammable. But they have a much lower global warming potential.
So they're a step in the right direction.
Yeah, exactly.
But safety is still a major concern.
Safety is paramount.
With flammable refrigerants.
And that's why there's all these strict codes and standards for handling and installing them. But the push for sustainability is driving that adoption. So it's a really fascinating area. Constantly evolving as we search for better and better alternatives.
It makes you appreciate all the thought and engineering that goes into something that we often take for granted, keeping our food cold.
Exactly. And even though we've covered a lot of ground here, it's important to remember that we've really just scratched the surface. You know, refrigeration systems can be complex. There's lots of nuances and intricacies. And while these basic diagnostic techniques can be really helpful, sometimes you just need that expertise of a trained technician.
Yeah, absolutely. But even if We're not planning to repair our own fridges. Having this basic understanding empowers us to be more informed consumers.
I completely agree. You can...
So we can spot potential problems early on.
Spot those problems.
Make better decisions about maintenance. And ask the right questions.
Ask the right questions.
If we do need professional help.
Exactly. Knowledge is power, right?
Knowledge is power, especially when it comes to keeping our cool.
Well said.
So where does this deep dive leave us? I feel like we've gone from fumbling around in the dark to actually having a flashlight and knowing where to point it.
I love that. We definitely illuminated some key concepts.
Yeah.
We explored the core of that refrigeration cycle, learned how to decode those pressure readings, and even uncovered the hidden importance of superheat and subcooling.
And who knew that tiny little TXV could cause such a big headache if it's not working properly?
Yeah.
It's like the old saying, for want of a nail, the shoe is lost.
Oh, I like that.
It's a good reminder that even the smallest components can have a ripple effect throughout the whole system.
They can. And
speaking of small things making a big difference.
Speaking of those.
We can't forget about those.
Often overlooked.
Often overlooked condenser coils.
Condenser coils.
Right. We talked about how dirty coils can restrict airflow and make the system work harder.
Right.
But it's more than just inefficiency, right? It can actually cost us money.
It can. Think about it. When your fridge has to work harder to cool, it uses more energy, right?
Oh, yeah.
And that translates to a higher electricity bill.
So it's a win-win.
Keeping those coils clean.
Clean coils, happy fridges, and happy wallets.
Save money. Okay, so here's something I was pondering as we've been talking. We've covered a lot of ground in terms of diagnostics, but what about the future of refrigeration?
Ooh, that's a good question.
What are some of the trends or innovations we should be watching out for?
Well, as we touched on earlier, that search for more environmentally friendly refrigerants is a big one.
Yeah.
Those A2L refrigerants we talked about, they're definitely a promising step.
Yeah.
But researchers are always looking for new alternatives. I imagine there are a lot of challenges involved in finding refrigerants that are both effective and sustainable.
Safety is huge, right?
Yeah.
And a lot of these new refrigerants require updated training and handling procedures.
Okay.
But the push for innovation is definitely strong.
Yeah.
And I think we're going to see some really interesting breakthroughs in the coming years.
It makes you appreciate all the thought and engineering that goes into something. We take for granted keeping our food cold.
And even though we've covered a lot in this deep dive, it's important to remember that we've just scratched the surface.
Right.
Refrigeration's a complex field. There's always more to learn.
Well said. I think this deep dive has given us a solid foundation.
Yeah, for sure.
And it's empowering to understand how these systems work, even if we're not all going to become HVAC technicians. So if there's one thing I hope you take away from this deep dive, it's don't underestimate the power of preventative maintenance.
So true.
Cleaning those condenser coils, checking the thermostat, even just listening for any unusual noises can help you avoid bigger problems down the road.
Couldn't agree more.
Until next time, stay cool, and thanks for joining.